This is an IBM Model 50021, one of the models from the launch of IBM's Personal System 2 in 1987. We have previously restored it, repaired the diskette drive and done a few upgrades. And in today's video we are going to build a custom sound card for it and finish this project. We left off this project last week by installing an McIDE controller, an 8514A graphics card, and adding more RAM with a RAM expansion card. This IBM worked perfectly while I was making the video, but unfortunately, right after the upload, it started to misbehave, so before we can continue we need to fix it. Occasionally the system hangs while booting to DOS, and sometimes it even reboots right after the XDID BIOS has loaded. Let's see how it behaves this time. This video is sponsored by PCB for a very good reason, as you will see later in this video. Thank you PCB for supporting this channel. No, it just hanged while trying to boot from C. And as you can see, we've got the same behavior when trying to boot from a diskette. So either something is broken in this machine, or quite possibly some weird compatibility issue. So let's start pulling cards and see if this issue goes away. Let's try without the RAM expansion card first. I'm using a real CRT because my modern display can't handle the refresh rate from the 8514A card. But 8513 here doesn't seem to mind at all. And we've got a 165 because we removed one of the cards. So I'll reboot with the ref disk in the drive. Okay, it reads and it seeks from the diskette drive. So this actually looks like it solved the issue, because it wouldn't even seek with the RAM expansion card installed. Let's run an automatic configuration. So now the IBM is removing the RAM expansion card. And that should also get rid of the 165 error. Automatic configuration complete. Okay, and now the machine boots. So that actually fixed the issue. But the weird thing here is that I have done a bunch of tests with this card in another machine. And in that machine it worked perfectly. So this may actually not be a faulty card. This could be some weird compatibility issue. I'll do a couple of reboots off camera and see if this is consistent. Well, I just did 5 successful reboots in a row, so it definitely has something to do with that card. By the way, I have tried with 5 different RAM sticks, so it's not likely bad RAM. Although I can't rule out that it's an incompatible RAM, so that is still a possibility, I guess. Well, since that card worked so well in another machine, I'm not quite ready to call it faulty. So next I want to check if it's incompatible with something in this machine. I have removed the 8514A card and installed the SCSI controller and an old mechanical hard drive. Now let's install that RAM expansion card again and boot the machine with the ref disk in the drive. And as expected, we've got a 165 because we have removed 2 cards and installed 2 other cards. The files for these 2 cards are already on the diskette, so we can run an automatic configuration. Automatic configuration is being run and configuration completes. Let's reboot again, and this time I'll eject the ref disk. And now it's counting up the added RAM. So we've got 1 meg on the motherboard and at the moment 2 megs on the expansion card, giving us 3 megs. And it has recognized the controller and the hard drive too. Okay, that's interesting. So now the machine boots. I'll do a couple of reboots off camera here to see if it's consistent. Okay, the tests are almost finished. And I just did 5 successful reboots in a row here. So this is clearly not a faulty card. It's either incompatible with the McIDE or the 8514A card. This is a pretty unusual issue. So for the next test I have installed 8514A card, but not XDID. So let's boot the machine up with the ref disk in the drive, because we're going to get a 165 again, because we have installed the card. And again I'll run the automatic configuration here, and then I'll reboot the machine. Okay, and it still boots. I'll do a couple of reboots off camera here to see if it's consistent. And unfortunately I just did 5 successful reboots in a row here. This combination works perfectly. Well, that really sucks, because this is kind of a perfect combination. The McIDE and IBM's 2 to 8 meg memory expansion card. Let me show you why. The Model 50 only has 3 MCA slots, but there is a slot hidden away inside the drive cage here. But this space is not large enough for a SCSI controller, but it is small enough to fit the XT-ID. So with that controller installed, we still have 3 slots for the 8514 graphics card, the RAM expansion card and a sound card. So unfortunately we're gonna have to ditch the 8514A card. It will still be a good machine for DOS adventure games, but unfortunately not as good in Windows. There's also another problem. The future domain SCSI controller only works with small hard drives. In a previous video we tried to modify a slightly newer drive. That trick worked really well in the Model 95, but unfortunately not with the future domain card. So this future domain card only works with actual small drives. I don't have any small SCSI drives that aren't completely worn out and really noisy. So we're gonna have to try with a different controller. So let's try this Tribble card here and see if it can handle this modified SCSI drive. This is an IBM branded 9.1 gig drive that we have modified down to 500 megs. We have successfully made this work in the Model 95 XP with a Corvette card, but I have never tried this with a Tribble card in the Model 50. Now this also introduces another issue, because the future domain card has a Molex for power and can power a hard drive, but the Tribble doesn't have a power connector, since it's not made to be used in the Model 50. So for this first test I'm going to use my badly hacked riser. I made this mod many years ago, before there were adapters to install regular diskette drives in Model 50s. So I basically bodged on a ribbon cable directly on the riser that will allow me to connect regular diskette drives. Now this mod is not needed anymore, because there are ready-made adapters like this one. But I'm going to use it because it has Molex power underneath. Okay, my hacked riser installed the Tribble card and the SCSI drive. The controller is tested, but I don't know if it's compatible with the Model 50. So we're just gonna have to test it and see if this works. I don't have the ADF files for the Tribble card on the ref disk, so I'm gonna hit no here and copy an option diskette. Well, I guess we could switch to a regular display, since we're not using the 8514A card. I'll swap it in the next reboot. Okay, remove ref disk. And I'll insert a diskette with the ADF files for the Tribble card. And now we can swap back to the ref disk. Updates of the reference diskette complete. Okay, now with the ADF files on the ref disk, we can run automatic configuration of the system. And if that card is compatible with the Model 50, it should now be installed. An error occurred while reading the option adapter file for the adapter in slot 3. Oh crap, so perhaps the Tribble isn't compatible with the Model 50. That sucks. Well, now it's configuring the SCSI devices and configuration complete. So what's up with that error? I'll reboot to the ref disk again and we'll see what's happening. Okay, we still have a 165, so it didn't install the card. I also noticed that the hard drive didn't spin up. So let's go to set configuration. And the error is back. Well, let's go to view configuration. Okay, and unfortunately we have an unrecognized adapter installed. So unfortunately it seems the Tribble isn't compatible with the Model 50. I'll do a quick check on Google before we try with something else. Okay, well I found an old forum thread. Someone trying to make this work, but unfortunately it was never successful. So we're gonna have to try something else. Okay, in that case let's try the future domain card with the SCSI to SD card. I don't have the proper cable for it, so bodge something together for now. And if this works, I'll make a custom cable. Okay, let's turn the machine on. Fingers crossed. If this doesn't work, this project is stuck with a really noisy old SCSI drive. I'll run the automatic configuration again. Okay, the 165 is gone. It found the future domain card. And a SCSI drive at ID 0. Let's hope for the best. No! The damn thing did a reboot! Oh crap, it crashed. Oh no, it crashed on the second reboot too. Okay, I decided to boot from a diskette and check in F-disk. If I remember correctly, we have tried this card in another video, so it should have a working bootable partition. But let's make sure. I think it's just a clean DOS installation, so we might as well just remove it and create a new partition. Now that drive is clean, so let's create a new primary partition. I'm gonna say no here and go for 250 megs, because we have only successfully run this machine with a 250 meg drive, and we can always increase the size if this works. Okay, and here's our partition, and I'll format the drive and make it bootable. Okay, and format complete. So DOS doesn't seem to have any issues with that drive. So why did it crash on boot? Well, I'll remove the diskettes and reboot the machine. Oh no, it totally crashed again. I'll reboot to the DOS diskette again. And we're back in DOS on the diskettes. Not very likely to fix the issue, but let's at least try with FDisk MBR and reboot without the diskettes. Okay, and on this boot it actually went to IBM PS. So it didn't crash, but it didn't boot either. Okay, let's try to boot on that diskette again and see if we have access to that drive at all. And we do! Wow, what a weird issue. The future domain card can't talk to that drive, but for whatever reason it doesn't boot. Well, this shouldn't make a difference, but let's try to install DOS proper and see what happens. Okay, proper DOS installed on the SD card. Let's reboot and see how it behaves. Okay, here is our SD card. Oh, it boots to DOS. Okay, so apparently that was just a messed up DOS installation, but how the heck did it manage to crash the entire system? That is pretty weird. Okay, but this is totally working. I'll do a couple of reboots and see if it's stable. Okay, that was 5 successful reboots in a row. So that card is totally working in the Model 50, together with that future domain card. Well, since rebuilding the master boot record fixed the SCSI to SD, I think we should try that same trick with an McIDE. It's the only card I have installed now, and I'm going to boot to the ref disk first. It's going to be the same procedure, so I'll skip ahead here. Okay, the system is configured. So now I'm going to boot to an MS-DOS diskette. And type fdisk mbr. And now I'm going to turn the system off and install the RAM expansion card again. And we'll see if it crashes again. I'll go through this process again to install that card. Automatic configuration complete. Okay, moment of truth. Was the MBR messed up on that compact flash card too? Or is this an actual compatibility issue? Okay, it counts up the extra RAM. It boots to XTID. Okay, it didn't crash. And it didn't get stuck when booting to DOS. Okay, but it did work a couple of times in the previous video. So I'm going to do a whole bunch of reboots now to see if this is consistent. And unfortunately it crashed on the second attempt. So that didn't fix it. I also checked all 3 diskettes we have used for boot sector viruses, because that would have explained why fixing the MBR solved the issue. But unfortunately they are all clean. Well, I don't know if the XTID is getting any bug fixes. Probably not. So we basically have to choose between the 8514A card or a sound card for that last slot. I'm obviously going to choose a sound card. For a 286 system, I'm gonna go with an AdLib card. So that gives us 3 different choices. The first option would be to find an original MCA AdLib card, but that is pretty much impossible. The second option is to use a pre-made card like this one here. It's basically an AdLib card, but it's made with modern components and has a modern look. The other option is to build Tube Time's PCB replica card. That has a much more vintage look to it, so I definitely prefer it. And I'm actually going to take it even further today. with the help of the sponsor of this video, PCB, because I've been playing around in KiCad and messed around a little bit with the silk screen to make it look a bit more vintage. There's not a huge difference. I have just removed a bunch of stuff in the silk screen and added an AdLib logo to give it some more retro look and feel. It's not meant to fool anyone, it's still clearly different from the original card. I partially did this mod for practice, but I also prefer this look. There is an old version of this project that uses the P82C611, but this newer version is compatible with more PS2 machines, and it's using a CPLD instead. Now, this chip is pretty damn expensive, so I'm going to do a small experiment here. Instead of buying one chip at Mauser, I went ahead and bought a whole bag of these for the same price at AliExpress. So I hope these are not fakes. I guess we're about to find out. Well, the packaging is definitely cheaper. They've just taped the chip down on a pad. When you buy them from Mauser, you get them in one of these really fancy anti-static boxes. Heavily padded on both sides. But for the price I paid for these, I'm not gonna care. The chip looks good, and the silk screen doesn't look fake, so it's probably an original chip. Just very poorly packed for hobbyists like me. Okay, so this is the only chip that could be a tiny bit tricky to solder if you're a beginner, but it's definitely not difficult. I won't be able to align it on camera though, because I basically have no space between the camera and the chip here. So I'm going to line it off camera and solder two of the pins. Okay, so what I did off camera here was just to hold the chip down while adding a small splash of solder on each side. So now the chip can't move and it's properly aligned. An easy thing to do, but very difficult with a large camera on top. Next I'm going to apply some flux. Then a large blob of solder on the tip. Then I'm just going to drag solder each side of the chip. I'm not going to care about the bridges for now. We'll remove them in a minute. I'll check and make sure all the pins got soldered. But first I'll drag solder all four sides. Okay, all four sides are drag soldered. But drag soldering like this always creates bridges. That's basically several pins soldered together. So, to remove them, I just need to add more flux. And then, without any solder on the tip, I can just drag the excess solder to one side. And some of it will stick to the tip. But if needed, I'll just clean the tip and have another go until all the bridges are gone. Okay, I think all the bridges are gone. So, next we can scoop up the flux. Otherwise, this is going to be a really messy build. Ideally, I would use the microscope, but I couldn't be bothered for just one chip. To get the flux up, I use a dry Q-tip. Then I scoop the flux up. Adding IPA with this much flux on the board will just create a bigger mess. And with most of the flux scooped up, I can use some IPA to get the stickiness off the board. I will of course wash this board, but that will have to be after the video. Otherwise I'm gonna have to wait for a day for the board to dry. Now that would delay the video for one more day. Okay, I checked with the loop and I couldn't see any bridges or loose legs. So here's the result. I'm only going to show you this good side. So we can pretend all four sides are this nice. And our next component is this voltage regulator. These are the only two surface mount components. And same thing here, I'm gonna have to align it off camera, because I only see the board from a really weird angle. Using flux on the voltage regulator isn't really necessary. But since I have it on the bench next to me, I'll use it. Okay, next up we have a bunch of resistors, and unfortunately I managed to order these absolutely tiny resistors again. I have done this mistake before, but luckily I have plenty of resistors in my stash, so we don't need to use them. Ideally I would have gone for regular beige resistors for a more vintage look, but this is gonna have to do. Okay, apparently I only messed up the size of one of the values. Remaining resistors were normal. Soldering bent leads should be illegal. Okay, that was the last resistor soldered, so we can snip the legs off and start installing something larger. So I'm basically starting with the thinnest components, and then I just move up in thickness. Next I ran into a minor issue here, because the volume knob for this project has gone obsolete. I found another part that I think will work and placed an order. I'll put some part numbers on the screen here, but keep in mind I have not tested the new pot yet. But once I have, I will leave some information in the comment section below. And for now I actually desoldered a trim pot from another card, because I want to finish and test this card today. Now we could also cheat like we did in another project and just solder a resistor across 2 of the through holes. But then of course we wouldn't be able to adjust the volume. Okay, sockets installed and soldered. Next in size we have a whole bunch of caps. Okay, that took a while, and some of them are tantalum, so make sure you get the polarity right. Otherwise your precious little card is gonna go bang. Next up we have a transistor here, and a 7805 up here. I had to bend the leads like this to make them match the footprint. And our last component to solder is the audio jack at the end here. Well, actually not quite. We're gonna need some pin headers to program that CPLD. I guess you could just push and hold the pin headers in while you program the chip, but I don't mind soldering a couple of extra pin headers. So I'm gonna do this proper. Okay, next up I installed the brand new chips from Mouser. And the remaining 2 chips are obsolete. So you're gonna have to hunt for these on eBay if you want to build one of these cards. So first is the Yamaha YM3812 and then the Yamaha Y3014B. Actually I went ahead and checked and ordered some more, and they are still available on AliExpress. And they are still cheap. And the final step, well except for adding a bracket, is to program the CPLD chip. And for this I'm using an Xilinx DLC9LP clone. I have done this in a couple of other videos, so I'm going to skip ahead here, but I will add a link to another video at the end of this video, where I show in detail how to do this. Well, I ran into a minor issue when trying to program this chip here. Apparently not all of the chips in that bag were 9572XLs. 2 of the chips, including the one we soldered to the board, are in fact 95144XLs. So apparently the seller was in a hurry and managed to throw 2 of these presumably more expensive chips in the bag. So we're gonna have to replace this guy to finish this card. This shouldn't be too difficult. I'll just add some flux. And then I'm going to use some chip quick SMD 4.5 to lower the temperature needed to remove the chip. This is not necessary, but it will make the removal much quicker. If you don't have chip quick, I found that just adding more solder will give you roughly the same result. So the way this stuff here works is that it stays molten for much longer than regular solder, making the chip removal very quick and easy. And then I'm going to heat the chip quick up with a rework station, making a bit of a mess here. If you don't have a rework station, you can just heat the chip quick up with a soldering iron. And if we gently push on the chip, we can see that it's now loose. Well, the difficult thing with this is to get it on camera actually. And the chip is off the board in just a few seconds. This method is very kind on the board and the chip, since it doesn't require much heat. Before we can solder the new chip, we obviously have to remove the chip quick. Trying not to make too big of a mess. Well, this blob is so big, I'm actually going to move it away from the board and just drop it on the bench. Then I'll add some fresh flux to all the pads and use some wick to make sure all the pads are perfectly clean from chip quick. I'm gonna have a second pass just to make sure none of the chip quick is left on the board, because it could weaken the solder joints. Well, luckily only 2 of the chips were wrong, so I still have some chips to install. I'm gonna have to align it off camera again. Well, I ended up soldering the chip off camera, not to repeat myself. So you guys may actually have noticed that I used the wrong chip much earlier in the video, because you guys are seeing this with way more magnification than I do. And with the correct chip soldered to the board, there was no problem programming the chip. Okay, card installed in the Model 50. Let's power it up. And I heard a loud popping noise in the speakers. That's a good sign. I'll install that card off camera, since it's the same procedure as with the other cards. This is an open source project, so you can find all the files you need on TubeTime's GitHub page. And if you want to build this slightly modified version, I'll make the files available and put a link down below. Now let's fire up some Monkey, see if that sound card works. And it totally does. Awesome. So now the Model 50 finally has a sound card. Okay, at this point I had actually given up because I didn't think there was a fix for this. So I ended the video and uploaded to my patrons. And that was the next day, and I decided to try one last thing, however unlikely it was to fix the issue. Now check this out, I've got all 4 cards installed, and the damn thing works. I just did 10 successful reboots in a row with this machine. So apparently there was a fix for this. So here's what I did. I removed the RAM expansion card and left all the other cards installed, including the McIDE. And then I ran FDiskMBR on that compact flash card. Removed the partition and created a new partition that was 250 meg large. And then I did a regular format and installed a fresh copy of DOS. And apparently that was the procedure to fix this issue. But then I tried with a different RAM expansion card, and the issue actually came back. So I would probably have to do that same procedure again to fix it. So there's definitely a glitch here between the RAM expansion card and the McIDE card. But apparently there is a fix for it. That's awesome. So there you have it. The Model 50 is finally finished after about 5 or 6 years. This is by far the slowest project I have ever done. Before you leave, consider subscribing to this channel, and I'll see you guys again next week.